My name is Caden Fricke, and this is my final project on black holes. A black hole is an invisible region of space where gravity is so powerful that nothing, not even light, can escape its pull. But how do black holes start? What causes these objects to be so powerful? It is something we've heard of in movies, cartoons, and other sources, so let's truly understand what a black hole is. They all begin with stars. Stars generate energy by burning fuel in their cores, but eventually, like everything, they run out of fuel, and when they do, the balance between gravity pulling inward and the energy pushing outward begins to fall apart and become skewed. The first thing that leads to a black hole is when a very massive star begins this process of imbalance, when their fuels run out, which leads to a massive collapse of a star. The core of the star compresses inward, and the gravity becomes so strong that it continues to collapse. The star's core shrinks into an incredibly dense point called the singularity, which is the center of a black hole. And finally, as this massive star collapses, a huge explosion called a supernova may occur, which shoots the star's outer layers into space, and the remaining core continues to shrink, forming a black hole, with gravity so intense that nothing, not even light, can escape from it. As black holes form, they can grow by consuming objects around them, or in some cases merging with other black holes around them. So the big question is, how do we study them? If it is something we cannot see because light cannot escape from it, nor is it something we can get near, how is this possible? The boundary of a black hole is called the event horizon. Once something crosses this point, it's lost forever, pulled into the black hole by its gravity. This is why we can't get near them, because with certain black holes, gravity would stretch you out before you even reach the event horizon, and this is known as spaghettification. Spaghettification happens when an object or a person gets so close to a black hole and doesn't pass the event horizon yet that the nearest point starts to stretch while the other is unaffected, pulling it apart. So how do we study them? Even though we cannot see them, their effects on surrounding masses don't go unnoticed. As matter like gases and dust get pulled towards the black hole, it forms a spinning disk called an accretion disk. As this material gets pulled into the black hole, it heats up, emitting bright X-rays that we can detect with powerful telescopes. One of the biggest breakthroughs in studying black hole came in 2017 when the Event Horizon Telescope captured the first ever image of a black hole. Its silhouette. This image reveals a black hole because of the glowing gases that surround it. Because the black hole emits zero light, they use the glowing gases around the black hole to highlight it with a bright background. But this is not the only way we can study black holes. We also use gravitational waves, which are ripples in space-time caused by events out of the norm in the universe. Things like black holes colliding and other big events. Instruments like the LIGO, which are instruments that are used with lasers far away from each other that enhance the gravitational waves in the universe, which help scientists learn more about black holes without even looking at them directly. The same effect is if you toss a rock in a lake and the ripples form far from the norm of the other ripples, and it is really easy to detect because it is so different from the others.